Good evening, this is Kavipriya, Assistant Professor, EC Department. Today I am going to deliver a topic called Characteristics of Measurement System. So the characteristics of measurement system is basically classified into two types. First one is static characteristics, second one is dynamic characteristics. So static characteristics are used to measure the quantities which are slowly varies by time or constant, mostly constant. So it does not vary with time. So it whether if the quantities varies with time, slowly varies with time, or if it remains constant, that is does not varies with time, then the characteristics that is used to measure those quantities are called as a static characteristics. So under static characteristics we have accuracy, precision, sensitivity, linearity, reproducibility, repeatability, resolution, threshold, drift, stability, tolerance, range, static error and dead zone. We can see each and every characteristics in detail. First one is accuracy. It is a degree of closeness with which a reading approaches the true value of quantity to be measured. And second one is a precision. Precision refers to the closeness of two or more measurements. So for example, if we weigh a substance 5 times and we get 3.2 kg each and every time, then the measurement is very precise. Precision is independent of accuracy. Precision can also, if even if the measurement is inaccurate, we even call it as imprecise. Next one is a sensitivity. It is defined as a ratio of changes in output of the instrument to the changes in the quantity being measured. It is denotes the smallest changes in the measured variable to which the instrument responds. Next one is a linearity. A system is said to be linear if proportional change in the input produces the same proportional changes in the output. Linearity is an indicator of the consistency of a measurement over an entire range of measurements. And next one is a reproducibility. Reproducibility refers to the consistency of measurements. It is extent to which the tool can produce the same result when used repeatedly under the different or same circumstance. Next one is a repeatability. It defines how the consistency is the output of the instrument. For same input is tried again and again under the same conditions. And next one is a resolution. Resolution is a ability of a measurement system to detect and faithfully indicate even a small changes in the characteristics of the measurement result. Next one is a range. The left extreme and right extreme value of quantity for which the instrument is designed to function is called as a range. Range is equal to maximum value minus the minimum value. Tolerance is the highest allowable error that is specified in terms of certain values which the measurement while taking the measurement. So the highest allowable error we call it as a tolerance. And next is a threshold. If an instrument input is increased very gradually from 0, there will be some minimum value below which no output change can be detected. This minimum value we call it as a threshold. And next is a drift. All calibration and specification of instruments are valid only under the controlled conditions of pressure, temperature. As a variation occurs in ambient temperature, certain characteristics even change. Such environmental conditions affect the output and instrument, and we call it as a drift. Next is a stability. Stability is the ability of a measurement system to produce the same values over time while measuring the same sample. And next is a static error. So static error is a true value of measured quantity minus indicated value. So it is a variation between the true values of measurable quantity to the values that is indicated by the measuring instrument, which are not affected by operating condition. Static error is positive. It means that instrument reads a high value. If static error is negative, then the instrument reads a low value. Next is a dead zone. For largest range of values of measured variable to which the instrument does not respond, we call it as a we call that as a dead zone. So the range of values for which the instrument does not respond or does not produce any output, we call it as a dead zone. And next is the dynamic characteristics of instruments. Some of our dynamic characteristics of instruments are dynamic error, response speed, fidelity, lag, retardation lag, time delay lag. So the dynamic characteristics are used when the instrument does not varies with time, so it produces a constant output. So dynamic error is a variation between the true values of measurable quantity to the values indicated by the measuring instrument, which are not affected by the operating condition. And next is a response speed. Response speed is defined as a rapidity of instrument to respond to changes in the measuring variable. How fast the measure, how fast the instrument responds whenever there is change occurs in the input value. It indicates how active and fast the system is. Fidelity is defined as the degree to which the measuring instrument produces changes in the input faithfully without any error. And next one is a lag. Lag time is a time taken by system to respond. Since every instrument takes at least some time to respond, so whatever time it may be to changes in whatever the time we call it as a lag. The time is based on the quantity to be measured. And next is a retardation lag. The response of measurement begins immediately after the change in the measured quantity. We call it as a retardation lag. Time delay lag, in this case, after the application of input, the response of measuring system begins with some dead times. Then we call it as a time delay lag. So that's all about the characteristics, static characteristics and dynamic characteristics of the measuring system. Thank you.